It's the same kind of analysis, but we're just going to deal with one section. So I go in here to color by feeder again, so we can see where these feeders are. I'm just going to grab this feeder and a substation. And let's just start out here on this. So I've got that set for analysis. You select a section for any application in Synergy that's dealing with a particular section. You always go in and do this set for analysis. So mine was already set, so unset. So I've selected that, DER here, and then I'm going to run this incremental hosting. I want my reports on for this. And now this is looking at just this section, and this is going to be a day in July. So it's a July day. Irradiance-wise, as far as the sunlight goes, it doesn't matter that it's a weekday. But the reason a weekday matters is all my loads. Because the loads throughout the system are going to have an impact on the hosting capacity. And so now we've got the delta voltage limit here, which is in the model settings. I've got mine set to 3 volts. And this is a difference in the way we're looking at delta voltage versus some other stuff out of the industry that you may see. And I'm not sure, but I think they're looking at delta voltage as more of a longer term after the tap changers have had a chance to operate. I could be wrong, and there's nothing wrong with that. Just want to make it clear that we're talking about intermittency here. So if that PV generator were to kick off, how much change in voltage would the customer see? And so if I get to 3.5 megawatts on that section, that's any more than that is going to hit my voltage violation. And this curve right here is reverse power flow. And you can see how it almost dips down. Sometimes it's pretty cool. We'll try some different locations, but these things start to overlap each other. So sometimes this will dip down, and but here the only factor for this location looks like it's delta voltage. And my thermal capacity is here. This is my low voltage limit here. Sorry, high voltage limit. We're going to put in low voltage on this thing too. And that seems like a weird thing to do if we're talking about PV. You know, it's a high voltage problem. Why are we worried about low voltage? And that's why I stress the fact that we are dealing with the substation, and it's important to model the substation in there. Even when I don't have this thing selected, it's going to analyze the full substation here. If I go and start looking at this feeder up here, and maybe this feeder has no PV on it at all, and this thing has a lot of PV, and if I have a compensator on my transformer, a line drop compensator in here, what could happen is that as my PV levels start to increase, this thing could start to tap down substantially. And so in order to keep the voltage managed on this feeder, and now all of a sudden I've got low voltage problems out here on this. And so today we're not checking low voltage on hosting capacity, but we will. So that you might be saying, well, okay, how much PV can I put down here? And it's going to be limited by some customer who's going to have really low voltage when you get to a certain level. So that's coming along, and who helped us? One of you all helped us to understand that more. I forget who it was, but anyway, thanks. Well, thank you. Now we haven't gotten into it yet, so it may be a nightmare. But. Okay, so let's try some different locations there. This one was out further. I'm just picking one feeder so it runs quick. Come in here and set this section for analysis, and let's run it here and see what happens. So now here we see the reverse flow limit is the dominant curve. The other two aren't even, I could put 10 megawatts here and not have a problem with, I can't even tell the colors, it's so bright here. But so this is thermal limit, this is reverse flow. And so reverse flow, like right here, you can see from 4 to 8 o'clock in the morning, it's going to be a thermal problem. And later in the day, it's a reverse flow problem. And that's, you know, the load and the generation are tied together. You know, it's a dance that's going on there. And you know, what to do with this data is fascinating. I try to ask folks about it because seemed like there's a lot of restrictions. You know, if somebody wants to come in and put in 5 megawatts, you know, and they say, okay, would you have a contract to say that they're going to curtail? And if you have them curtail and conform to this kind of curve, how do you enforce that? And these loads, you know, we have good solid models for the loads, but next year, who knows what's going on? And if new loads get added or loads get dropped, then all this stuff is going to change. So it's solid stuff, it's good, but you know, what to do with it is, you know, it's a challenge for you all. It's fascinating to me, so
So Larry, we have a new program now that during the daytime it's going to be a non-export system, and then during the rest of the time they can export out of that.
Okay.
So, you know, I can see how this application will be kind of needed in the park circuits to model how can we accept those types of systems.
Okay, got it, yeah. So Reed's saying that they, some situations they have requirements that a customer would be non-exporting during the day and exporting at night, so that they have storage of some sort, right, batteries, and that's a big deal. We have, you probably saw at the time, the single day analysis, we do battery modeling. There's a big one that's on this model right here that's affecting the hosting capacity. I've got a large battery. This thing it's got a nameplate value of 1 megawatt, I think it is. Yeah, it's a 1 megawatt battery. We've got efficiencies here for discharging and charging. This is it's neat. I think when you start studying these batteries, the efficiency, the impact that it has on the schedules, because our batteries are usually schedule driven, and so how, you know, 84, these are pretty typical values, and so you've got a schedule that says, okay, my battery needs to be discharging for this period of time. Well, it may run out of its, I didn't mean on the zero there, but out of this, the energy level, it may dissipate before it has a chance to hit that full production. And then it may take longer to charge than you expect. So it runs shorter and takes longer to charge. And then the ramp rate, all that kind of stuff we're dealing with. So there's a lot going on the battery side. Just while I'm talking about batteries though, this is a large battery. We have work to do at the customer level. I showed you customers yesterday, I'll get into that more. But we do customer modeling, and we've got to get the batteries into that. And so that's coming along as well. Okay, let's talk about this. There's some other hosting capacities that I'll talk about here. I don't want to run out of time. Let's go to this next thing, which is a screener. And yeah, the settings aren't much to look at here, but let's just run it. And this thing is running over, so I've got, yeah, let me get a different location, so maybe a little more interesting. I want to set a location and say, this location right here, let's say. And I go into the screener and I want to put in 20 megawatts, which is a lot. I'm going to put in 20 megawatts right here. And then we run the screener. And we were talking about this, Don. So this is the application that we have in place. And that's what's a little more interesting here, but we're across the top of the report here. We're starting with nothing. This is the base case. And we're running out to 20 megawatts here. And then these are the screens. And so we've got some official looking tags on these. And then this first one is feeder loading. And you can see delta voltage, reverse flow, and so on. So we've got 7 screens in place. And we've set this up, we've built this so that we can add more. So you call us or email us and say, hey, this is a screen I'd like to have in the application. It's going to be DCS 80. Or maybe if it's sort of like feeder reverse flow, we'll make it DCS 31. So hopefully we can use these gaps in numbers to kind of group things together. And so we'll put in more of these screens. So the place where we see this a lot is the New York Rev. They have A through, is it I or J or something like that? Have you guys seen that? Screens. So one of the screens they have is kind of neat that we don't have in here is a recloser, the load fed by a recloser, the generation should never exceed the load on a recloser, something like that. So if we put that in, that'll be VCS 80 here. Okay, so looking across here, let's see what, sorry, just a second here. See if I can make this a little more interesting. Let's see what I did wrong now. There we go. This thing is running over my 4 or 5 months, 24 hours a day. There we go. So this thing ran 2,600 hours. And now I look across here, and when we get to 4 megawatts, these numbers are percent. So 10% of the hours, so about 260 hours, I'm going to hit a reverse flow violation at 4 megawatts. And so we're doing this because this is a model, it's fed from data, and there's just a lot of uncertainty going into all this. And so we don't want to say, no, you can't put 4 megawatts out there, because as an engineer, we might look at this 10% and say, that's really insignificant because of those reasons. But now when we get to 6 megawatts, we've got almost 50% on the screen, and then we've got 100% on conductor loading. So 100% of the time, I've got a problem at 6 megawatts. So, I might say, well, 5 megawatts is the most we're going to put at that location. So that's what we're trying to do with the screener. Make it run fast, make it simple to see, run over time, and present you how often, how much of my window am I going to have problems with this generator. We hope that you all can take advantage of this. If you're using other systems and you need to do screens, it's there for you to use. There's a lot of stuff in the industry, and we're not out there trying to say, use Synergy Electric if you're looking at using other folks, other groups or consultants or whatever. It's our job to make sure you guys have the tools you need to do your studies. And like I said, this is fundamental stuff. We would love it if you use Synergy for these things. You make Synergy a part of your ecosystem. I use that word again. To try to leverage it, because you have a consistency between your planning group and the other parts of your utility that are using these studies. So we can be turned into an engine to do these kinds of studies.
Before you move on, so the screens would be something you guys have to add into the software as
We
well?
do, yeah.
Okay.
That's right. It's because it's a lot of work to try to make this stuff open on this side. I mean, all the data imports, everything, we work hard to make all that open. But these kinds of things, it's just so. But we'll try to respond very quickly. And if
I'll just say one, because one of the New Mexico ones is comparing the generator fault current to a ratio of that to the fault current at that location.
okay,
So,
well, we should get that in there then. Yeah, if you can email that, the details on that, that'd be great. We'd love to put it in.
Is the voltage settable, or are these the limits settable in these?
Yes, that's right. They're just in this normal exceptions place. Yeah. Yeah. So there's.
So we can't edit anything, any of the parameters for these screens?
It's just the normal model options. So if a voltage violation is going to be, this high voltage, or sorry, low voltage, high voltage value right here. So if 126 is going to be a problem on voltage. So we're using the same exception settings that are used everywhere at Synergy. Maybe that's not good. We're just trying to avoid any new settings. And so if you saw that application settings, they're today, this is all there is how big is it? Even these things that we're probably going to take out. So how big is the generation in megawatts, and then the time range? Because you could just run it for the particular hour you're in, July weekday 11, or over our range here. We are going to have a list in here that's like, it's going to end up looking like this, where there'll be a list. These are coordination rules for check coordination, but those screens would show up in a list just like this, and you just come in and turn on the ones you want. So if there's stuff in there, you can take it out and okay. So let's look at some of the other hosting capacity. Get rid of some of these reports here. One that is more about the feeder level hosting capacity is this GROW approach. And with the GROW approach, I think there's a saturation level in the setting. It's not even that. And so it's just going to start adding PV throughout the feeders until it runs into a problem. So if we run this, we get a list of all the feeders in here, and then we have how much. So this feeder, New Big Spring, has almost 4 megawatts PV on it, and it can get up to about 9. And so we've got about 5 remaining. So we look across here to say, okay, what is the limiting factor? We can, and so it's, I'm sorry, the reverse flow. So the substation hits our